Okay, so in this video, we're going to go ahead and take a look at some control structures. So in particular, we're going to look at two things. One is the for loop, and we're also going to use a variation of the while loop in this program. So have you ever wished that you could get your computer to just simply do your math homework? Well, in this case, we're going to go ahead and we're going to try to get our Arduino to do some math. Uh, so the question that I want to kind of approach here is, how can you get the sum of the first 100 perfect squares? So that means we're going to go through and take 1 and square it, and add it to 2 squared, add it to 3 squared, add it to 4 squared, and so on until we get through 100 squared. As you can imagine, that could take quite a while for you to do. There are some formulas for doing so, but I want to go ahead and make our Arduino do that homework for us. So the first thing I need to do is set up some variables. So the first thing I want to do is go in here, and I'm going to give my integer variables in here. We're going to use intx. We're going to set that equal to 0. Do inty equal to 0. And we're going to do int, actually we're going to change this, rather than int, we're going to use long. So long allows us to use larger numbers, because our numbers are going to get rather big. And we're going to call this one sum. We're also going to initialize this to 0. And so that's going to take care of the necessary variables that we need. So what I want to do is go into void setup. Now we're not going to use any kind of hardware, so we don't have to worry about any pin setup or any kind of those things. But we are going to go ahead and use our serial monitor. So we need serial.begin. And of course, we're still communicating 9600 baud rate. So what I want to do is take a look at the for loop structure. So the idea of this is I really want to get into understanding what is happening in some of these control loops. So the first thing I'm going to do is I'm going to initiate a local variable that we're just going to call I. So we're going to say I equals 0. So int I equals 0. We use a semicolon. And then we're going to say that we're going to do a test. For all I values less than or equal to 100, use our semicolon again. And our next condition is an increment. We're going to just say I plus plus. And so what this says is we're going to start a loop. We're going to start at I equals 0. And we're going to move from I equals 0 through I equals 100, incrementing one step at a time. And when we do that, it's going to execute whatever code I put in my curly braces. So let's go through and look at what kind of code I could put in my curly braces so I can approach the problem. So again, the problem was, how can I find the sum of the first 100 perfect squares? Well, first thing I need to do is figure out how do I come up with the perfect square. So if y, we've already initiated this at 0, we're going to say this is POW, in parentheses, you have your base and then your power. Our base is going to simply be x. Our power is going to be 2 because we're going to square everything. So what we're going to say is y equals power x squared. Okay, so that gets us all of our x squared values. Well, now we need to go through and be able to increment x so that we keep increasing it. So we're going to go through and just simply say x equals x plus 1. So each time it loops through this code, it's going to continue to add another 1 to x. So it'll start at 0, it'll go to 1, then the 2, then the 3, then the 4, and so on until we do this increment 100 times. Finally, we need to keep track of all this. So we're going to say that our sum is equal to sum plus y. So this is going to keep a running tally for us. It's going to take the value that we have stored in the variable sum, and we're going to add y back to it each time. And finally, so we can see what's going on, we're going to use serial.println. We're going to tell it to print sum. Okay. So I'm going to leave the code right to here, and we're going to upload this and take a look at what it does, and we're going to come back and modify this just slightly. So let's go ahead and upload. We're going to have to save it. We'll call this sum, and this is compiling. As soon as it says done uploading, we want to hit our serial monitor button. So we hit our serial monitor, and it's going crazy. The numbers just keep going on and on and on. So we're well beyond 100 values. So how do we stop it after 100 values? So we're going to close it. So what's happening is, in the for loop, it's going through and it is summing the first 100 values, but then it's looping back over again. And it continues to do this. So once it's done the first set of 100, it's moved on to the second set of 100. So we need to be able to interrupt this loop to actually make it stop what it's doing. To do this, I'm going to use a special instance of while. So while, let's go ahead and just set this up. We're going to say int, we're going to set up a variable. We're going to say we'll make a variable equal 1. And we'll do a instance of while, where we put in parentheses a test. So the way while works is, as long as the test is true, it'll stay in the loop. So if I just go through and say that while var is equal or is 1, actually I can just do equal 1, do what's in the curly braces. And I'm going to put absolutely nothing in the curly braces. And what this is going to do is it's going to hang up the program. It's going to go through the first 100 numbers, and it's going to enter this while loop, and it's just going to sit there. So watch what happens. We're going to upload it. What did I get? I have an extra curly brace. That's why it's yelling at me. Try to upload that again. This is done uploading. We're going to hit our serial monitor, and it's going to spit out the first 100 values, and it stops. So the for loop had incremented all 100 values, summed them all up, and gave me a full list of every one of those. So I can even scroll back up, and we see it'll start out with 0, and then 1 times 1 is 1, plus 2 times 2 is 4, so 1 plus 4 is 5. And it's going to keep doing this over and over again. Well, by the time you get through the first 100 iterations of that, you end up at 338,350. So you've just written a program that will check your math homework for you. Let's say, for example, you wanted to do it in the first 25. We can go through and we can just change that value to 25. Hit upload. Done uploading. Hit serial monitor. We get 5525. So we can go through and we can change this number here, and we can make this do as many squares as we want. If we go to 200, upload, we can change this value all day long. And our Arduino is going to simply do the math for you. Computers are really good at doing repetitious work. If, say, for example, you want to change the function that we're plugging in there for this summation, we can go through and change the y equal value. If we just change it to x plus 1 and say we want to know what is the sum of the first 100 integers is what this will spit out. Is you take x plus 1 and then 2 plus 1 and 3 plus 1 and 4 plus 1. That's exactly what this is going to do. We upload and hit our serial monitor, and you'll see it'll sum it very quickly. You have 5,151, which is the correct answer for the sum of the first 100 integers. So this is one way we can use our control loops. Now, if we were doing this with, say, for example, an LED, we can step through brightness, making this fade in and out, utilizing a for loop. We could do this on a motor for increasing and decreasing speed. So just because we're using an example of numbers here doesn't mean you can't use this. So the idea is that you're trying to do something that's going to step through progressively. And this is how we want to use control loops to do this. We could have done the same thing with while loops. We could have accomplished this with a while loop where we had to go through and count the while loop 100 times or 200 times, executing what's in it until it exits that while loop. So again, thank you for watching, and I'll see you in the next video.